All right, so today we're going to be talking about Graham's law. And in order to talk about Graham's law, we have to talk first about temperature. So before we talked about how temperature it tells us how fast the molecules are moving. But this is kind of an inaccurate definition. The better definition, I want you guys to write this one down, is actually temperature is a measure of how much kinetic energy the gas molecules have. Okay, so I'll talk about what kinetic energy is in just a second. But just make sure you write down this new and improved, more specific version of the definition of temperature. Okay. Temperature is how much kinetic energy the gas molecules have. Okay, so kinetic energy is the energy from movement, right? Kinetics means moving. So let's think about it this way. It's an easy way to think about it. So let's say that this is me, okay? I'm gonna draw myself, right? And this is you on your bicycle, okay? You're riding a bike. And you're traveling at, let's say, 20 miles per hour, and then you hit me, okay? So boom, I get hit by you on your bike, all right? So just think about the force of that. I get kind of hurt, it would hurt, but let's put you in an object that has more mass, okay? So let's say that you are driving your car, you just got your license, okay? And you're driving your car at 20 miles per hour, okay? And you hit me with your car. Okay, which one is gonna hurt more if I got hit by you on the bike or in the car? Okay, obviously the car, right? Why would it hurt more? Yeah, there's more mass, and that's what kinetic energy is. So kinetic energy is how much energy an object has while moving, and even if you're moving at the same speed, right? If you get hit by something that has more mass, you have more kinetic energy. Does that make sense? Yes? Okay, so even if you're moving at the same speed, mass matters in the kinetic energy as well. And so this goes the same way for gas molecules. We talked about how gas molecules are flying around. They have kinetic energy. And this is going to be Graham's law right here. So the smaller the molecule, the faster it has to move to generate the same kinetic energy, okay? Which means to be at the same temperature. So let's say that we have a small gas molecule. Okay, and let's say that we are at, I don't know, 25 degrees Celsius. And we have a big molecule at 25 degrees Celsius. Okay, what Graham's law is basically telling us is that the small gas molecule, this guy has to move faster. Okay, even though they're at the same temperature, because it needs to generate the same amount of kinetic energy. And this gas molecule, the big one, is going to be moving, not smaller, slower. Okay, so this is basically a summary of Graham's law right here. Okay, the small gas molecule, it needs to move faster to generate the same kinetic energy, to be at the same temperature. Okay. And that's it. That's Graham's law. And I'll show you guys how we can do that in a problem. It's actually really, really easy. You guys already know how to do it. All right, so Graham's law actually leads to two different phenomena, and both of them can be explained very well with farting. Okay, so I'm going to use farting as my example. Hi, welcome. Okay, so the first phenomena that we're going to talk about is something called diffusion. You guys might have heard of this term before in biology. And diffusion is when one substance mixes with another. Okay, so make sure you guys jot down the definition. Okay, diffusion is when you mix one substance with another. Okay, so if I can describe diffusion just very briefly, it's as if, let's say we have these gas molecules here, and let's say this is your fart. Okay, and there's something preventing your fart from spreading out. Okay, diffusion is a phenomenon where if you get rid of this wall right here, the gas molecules, your fart, will spread out and fill the container. So if I farted right now, eventually it would spread out to the rest of this room. That's what diffusion is. Okay, make sense? All right, so let's talk about that in terms of Graham's law. Okay, your fart is made up of a lot of different molecules. Okay, some of them are big and some of them are small. Okay, and because some of them are big and some of them are small, they're going to travel at different speeds. Okay, so let's say that we have a very small gas, okay, H2, okay, versus something a little bit bigger in your fart like CO2. Okay, so H2 is a small gas, CO2 is bigger. Which one do you think is going to spread out across the room faster, H2 or CO2? So we said small gases move faster, big gases move slower. If I released these two gases at the same temperature into a container, which one would make it to the other side first? Yeah, this one's going to make it to the other side first, okay? So H2, since it is faster, it means it spreads out first. Okay. And I think this is why there's a delayed effect when somebody farts before you smell it, because the smelly gas molecules, they actually are heavier than the non-smelly ones. And that's why there's a delay effect after you fart. You say your fart's yellow. All right. The next phenomena is going to be something called effusion. So make sure you guys write this down, effusion. And I think when you read the definition, you'll understand why I said fart is a good example of this phenomenon. Okay, it's when a gas escapes from a container through a small opening. Okay, effusion. All right, so again, effusion is the escape of a gas from a container through a small opening. Again, your fart does that all the time. And you are that container. You never even smelled my fart, weirdo. From what you've heard? Oh. So effusion is very similar to diffusion. The only difference is instead of removing this partition, there's a small hole instead. Okay, so let's say you have fart right here. Okay, it's gonna go through that small partition or that small opening, and it's gonna spread out. And it's the same thing as diffusion right here. The smaller gases, okay, they spread out faster. Ooh. Okay, so that's diffusion and effusion. Any questions on those two? Pretty simple to understand. Okay. All right, and those are the last two definitions I'll teach you guys this year. Okay, I know it's coming to an end, guys. I feel like I'm just getting to know you. Now you're leaving me. All right, so let's go over one last practice problem together, and then I'll get you guys started on your, that's not your last assignment, but your assignment for today. Okay. All right, so you guys already have Graham's law. I'm going to show you guys how to solve a Graham's law problem, okay? So in this problem, we're going to be taking a look at a bunch of different gases, okay? So I actually looked this up, and your fart is made up of the gases below, okay? So all these gases right here. And basically what you're trying to figure out in this problem is if you farted, which of the gases would make it to the other side of the classroom first, and which one would make it there last. And it's very easy to solve this problem. The only thing you need to do for Graham's law, and the reason why I said you need your periodic tables, is because you're going to look for the molar mass of all of these compounds, okay? So I'm going to actually stop right there, and I'm going to give you guys 3 minutes. I want you guys to work with the people next to you, and you guys can split it amongst yourselves if you want, but I want you guys to find the molar mass of each of these chemicals right here, okay? N2, O2, H2, CO2, CH4, HS, okay? So again, I'll give you guys about 3 minutes to do that. You're going to find the molar mass of all of these chemicals. Again, feel free to split it with the people next to you. And then once you find the molar masses, I want you guys to try to use those numbers to figure out which gas gets to the one side of the room first and which one gets there last. Okay, so I'll give you guys 3 minutes to do that. Okay, so very briefly, molar mass. You guys should be familiar how to do this. You just pull up the periodic table. Let's start with N2. You just look for the molecules or the elements that make up the molecule. So you got nitrogen. There's 2 of them. So you got 14 times 2. So N2 has a molar mass of 28 grams per mole. Okay, and all the numbers here will be grams per mole. Okay, so you kind of just go down the line. Oxygen is 32. Hydrogen is 2. Carbon dioxide is 44. CH4 is 16. And then this one is 33.07. All right, so those are the molar masses of all the gases. Okay, any questions on how we got those? Hopefully not too bad. All right, so let's figure out which one moves to the room, other side of the room first and last. So let's think about them in terms of Graham's law. Does the smallest one move faster or the biggest one move faster? The smallest one moves fastest, right? So since the smallest one is fastest, that means that the smallest molecule will make it to the other side of the room first. And then obviously the inverse is true for the other one, because the largest one is the slowest. That means that one is going to move to the other side of the room last. Okay, so based on these gases, which one is the biggest gas molecule? Yeah, CO2. So the CO2 is the molecule that will move to the other side of the room last. And then obviously H2 is smallest, so it makes it to the other side of the room first. Okay, and that's it.